Today we will be dealing with two problems that are related to Newton-Raphson's method. So the first problem, find the root of the equation x square plus x minus 5 is equal to 0 up to 3 decimal places. You have to find the root where the 3 decimal places is same in the consecutive roots, for the consecutive roots. That is, you have to find it till xn is equal to xn plus 1. Okay, now regarding that we will discuss that point later. Now let's find out the solution, and let's see what all are given in our question. What is the data that is given in our question. So the solution for this particular problem is that you have to keep in mind the formula for the Newton's Raphson's method. I hope by now you know the theory part of Newton's Raphson's method. So just write the formula in a piece of paper. Okay. Now, from the question it is clear that f of x is equal to x square plus x minus 5. You have to find out f dash of x, since in your formula you will have to substitute f dash of xn. So before that you have to find out what is f dash of x, and I hope you all know how to find f dash of x. So f dash of x is nothing but 2x plus 1. Now you have to find out the initial root. So the initial root somewhere lies between two numbers. We do not know which are the two numbers, but to find out the two numbers we can adopt the method that we have done earlier. Just find out f of 0 first, and you will get a negative value. Then find out f of 1, so you will get again a negative value. Again go for f of 2, you will get a positive value. Okay, so here you have negative and positive consecutively. You have got the result. So your root somewhere lies between 1 and 2. Okay, now you can take the initial root. So usually you denote the initial root as what? X naught. So you can take the initial root in this case as 2, since this is very much close to 0. That is, f of 2 is equal to 1 is closer to 0 than f of 1. Okay, so that is why I took x naught is equal to 2. Is fine if you take it as 1. The initial root is absolutely fine. The only thing is that you might end up in some more steps. Okay, or you can take a middle value, that is somewhere between 2 and 1, that is you can opt for 1.5. okay, it's up to you, but the only thing is that the initial root should lie between 1 and 2, or else you can take 1 or 2. It's up to you according to your convenience. So now this is the formula that you have studied in your theory class, right? xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So let us find out what is f of xn. F of xn is equal to xn square plus xn minus 5. Okay, now what is f dash of xn? 2xn plus 1. Now it is easy to substitute these two equations in the formula. Okay, now let's start the iteration. Now the iteration, as usual, we begin from n is equal to 0, and we already have with us the initial root, and the initial root is x naught is equal to 2. So when we substitute n is equal to 0 in this particular formula, you get x1 is equal to what? X naught minus f of xn. F of xn, what is f of xn? Yes, xn square plus xn minus 5. But here you have to see that here it should be x naught square, because you have already given n is equal to 0. So x naught square plus x naught minus 5 divided by 2x naught plus 1, which is equal to, what is x naught? It is 2. So 2 minus, substitute the values over here. You will get 4 plus 2 minus 5 divided by 4 plus 1, which is equal to 2 minus 1 by 5, that is equal to 1.8. So your x1 is 1.8. Now you have to find out the next root, that is x2. So the next iteration, that is the second iteration, is x2 is equal to x1 minus f of x1 divided by f dash of x1. Okay, now you have to substitute the values for x1. So already in the first iteration you have obtained the value for x1, and that is 1.8. Substitute the values over here in this formula. Then you will get the value, after calculating you will get the value 1.7193. Okay, so next so just check whether x2 and x1 both are equal. No, so you have to do one more iteration, that is x3. Now similarly you find out x3, you will get 1.7912. Okay, so again you will have to do another iteration, that is x4. So there you will get 1.7913. So here the three decimal places are same, that is x3 and x4 are same. Hence the root for this problem or the solution for this problem is 1.791. Okay, so I hope you all understood the method. Now let's move on to the next problem. So the next problem is to find the roots of the equation of equation 3x is equal to cos x plus 1 up to 4 decimal places. Now as you can see here, a cos term or a trigonometric term is involved. That means this is a what kind of equation? Transcendental equation. Okay, so let's move on to the solution part. Now here you will have to rearrange this equation in such a manner that it would be easier for the further calculation. So how will you rearrange it? F of x is equal to 3x minus cos x minus 1. Okay, so again you will have to find out what? F dash of x, right? Why? Because the formula is this. We are doing a Newton-Raphson's method for this problem in order to find the root. So xn plus 1 is equal to xn minus f of xn divided by f dash of xn, right? Now since you have an f dash of xn in the denominator, you will have to find the you will have to differentiate this function. Okay, so when you differentiate the function, what will you get? Yes, now I'm going to write this as terms of xn. Okay, f of xn is equal to 3xn minus cos xn minus 1. When I differentiate it, I get 3. Then when I differentiate this trigonometric term, what will I get? Minus sin xn. There is a negative sign over here, so minus minus will become positive. So that is how you get 3 plus sin xn. Okay, now this term is a constant, so that is 0. So f dash of xn according to this problem is 3 plus sin xn. Now what you have to do is you have to find out what? Yes, to find out the initial root, you have to find out 2 points A and B. Okay, we should know where our root lies. Now for that I just gave the function 0. For x I gave 0. So f of 0 is minus 2, and when you see my next line, you will find that I gave f of 1. Now f of 1 is equal to 3 minus cos into 1 multiplied by 180 divided by pi. So why I did this? Because this is in radian. I have to since we are using a trigonometric function over here, I have to convert it into degrees. So that is why I multiplied 1 with 180 divided by pi. So when I multiplied with 180 divided by pi, I got the answer as 1.4598. Now, when you do this in your calculators also, you might get this answer. Now there is another method. I will forward you the link later. Okay, so yeah, so for the time being you can multiply this 1 into 180 divided by pi, and you just convert it to that degrees. Okay, now so it is clear that you are getting a positive value over here, a negative and a positive. So your root lies somewhere between which numbers? Yes, 0 and 1. So again, according to my convenience, so it is up to you, as I always say, but for my convenience and your convenience also, I'm going to take the initial root x naught as 0. Now we are going to start the iteration. Now the first iteration is x1. So again here I'm going to give, I hope you remember the formula. Now in the formula I'm going to substitute n is equal to 0, and my x naught, or the initial root, is also 0. So when I substitute that, I get x1 is equal to x naught minus 3x naught minus cos x naught minus 1 divided by 3 plus sin x naught, which is equal to 2 divided by 3. Just substitute the value 0 over here, you will get the answer. Okay, then and the answer over here is 0.6667. Now again you are going for the second iteration. So the second iteration is x2 is equal to x1 minus 3x1 minus cos x1 minus 1 divided by 3 plus sin x1, which is equal to 0.666. What is 0.666? Your x1. So I substitute, we have already obtained the value of x1 over here, so I just substitute the value over here, minus 3 into instead of x1 I wrote this, and inside the cos x1, so here happens the magic, cos, so x1 is 0.6667 multiplied by 57.3. Now what is this 57.3? It is nothing but 180 divided by pi. So here also in each iteration I am going to convert this into degrees. So the 180, instead of this, if you write 180 divided by pi, it is also fine, but the value of 180 divided by pi is 57.3. So for my convenience I wrote 57.3. okay, so and that divided by 3 plus, again you have a trigonometric function over here, a term, so you will have to multiply it with 57.3, that is 0.6667 multiplied by 57.3, and finally your answer will be 0.6075 for what? X2. Okay, so the X2 that you get is 0.6075. Now you have to find out, go for the third iteration. Why you have to go for the third iteration? Because when you compare x1 and x2, there is nothing much similar about the x1 and x2 except for the first decimal place. So let's move on to the third iteration. For the third iteration, I give the equation like this. I substitute the values of x2 wherever it is seen in the formula. And again here also you have to note that I am converting the radians into degree. That is 57 point, if I multiply it by 57.3, I will get the answer as 0.6071. Okay, now is there any similarity between this? Okay, now you have 3 places, right? So but we were asked to find out 4 places, so let's move on to the fourth iteration. So the fourth iteration I haven't done, that I leave it to you. So you find out x4 and just check whether you are getting this answer, that is 0.6071. okay, so if you are getting that answer, that means you can stop the iteration and the root is 0.6071. So hence this problem is solved, that is the second problem is solved. Now yeah, now this one is a homework for you. This one is this equation is the one that confused me and you a lot. Now that is a simple one. It was my mistake. So I'm giving this as a homework. I hope you all have understood the procedure to find out the root using Newton's Raphson's method. So you can take this as a homework and work it out, and and find out the root of this equation: x cube plus 2x minus 5 is equal to 0.